Okay guys, now we'll be doing chapter 2, how to write molecular formula and how to name from the molecular formula. So there will be primarily 7 types of molecule we can categorize. The first one is ionic compound. Ionic compound with main group metal, because ionic compound is metal and non-metal. You know that part, right? So ionic compound could be main group, could be transition metals. So could be main group and could be transition metals. So could be transition metals. Ionic compound also could be polyatomic ions. Polyatomic ions. So the 3 types of ionic compound. And the 4th is covalent. The 4th types of molecule is the covalent compound. And then then 5th is acid. Acid are 2 types. One is binary acid, other one is oxyacid. And the last type is called hydrated salt. These are the 7 types of molecule we can categorize of. The first one is main group metal. Can you give me example of main group metals? Iron. Look at the periodic table. Okay, tell me who are the main group first in the periodic table. Who are the main group? Group A, 1A and 2A, right? And then 7A, yes, even 3A, 4A, 5A, 6A, right? So these are called main group. What are the transitions? In the middles, yes. They are the transition metals, right? So first category is the main group metals. What are the main group metals? Give me the example, please.
Hydrogen.
So metals are the left side, all of the metals, right? Until the staircase. Remember?
Oh yeah, the staircase.
So metals are left side, non-metal are the right side. So give me the example of main group metals name.
Aluminium.
Aluminium. So aluminium. So if we try to go ionic compound with the main group, ionic compound is metal and non-metal. So with the main group, I got a metal from the main group. Give me the non-metal name.
Phosphorus.
So phosphorus is not the non-metal here. Non-metal are all the right side. Nitrogen, oxygen, fluorine, chlorine, bromine, sulfide, iodine. These are called non-metals, okay? So let's say aluminium oxide, okay? So you learn how to write molecules. They correspond their charges. So aluminum is a 3+, oxygen got it. And aluminum got 2 because oxygen is 2 negative. Because of the location of the oxygen in the periodic table, right? So oxygen, so charges goes to subscript in a molecule. right? That's called aluminum oxide, and this is the main group. This is the ionic compound with the main group metal. So the naming is very simple in here. The naming, the way it goes is you say the name of the cation, which is aluminum, and say anion with IDE. So if you write the formula way, you can say metal, say the metal name, then non-metal name, and then plus IDE. The name of the aluminum would be aluminum oxide, right? You added IDE. So this IDE is for non-metals. All non-metals in a compound become IDE. It could be ionic, it could be covalent compound. It always become IDE. So the second type is called transition metal ionic compound. Ionic compound with the transition metals. So in these transition metals, give me the name of transition metals. Iron. So iron is a good example of transition metals. And iron have a multivalency. Iron valency is two types. Could be 2 plus, could be 3 plus. So many transition metals have a double valency. Sometimes 2, sometimes 3, sometimes 1, 2, or 2, 3. So for instance, iron could be 2 plus, iron could be 3 plus, right? So when you write ionic compound, these charges will go to subscript. So if you make with a chlorine, that would be iron chloride, iron Cl3, right? So these two coming from charge of iron, these three coming from charge of iron, and chlorine charge is 1, 1, becoming 1 in here, 1 in here, right? So the naming goes, so you write this iron chloride would be, you just write the name of the metal first, iron, and then in the middle Roman numeral, and then write chloride. Chloride, right? Iron chloride. And if you have other one, that would be iron 3 chloride, okay? So instead of 2, it's going to be 3 because it is a 3 valency, right? So that's how you name for. So what's the difference between main group and transition metals? The difference is only one. Here you look at the charges, but this one you don't look at the charges. You just write as it is, aluminum oxide. We don't need to look at is it 3, is it 2 or 1. The third one is called polyatomic ion. Polyatomic ions is, remember example of, can you give me example of polyatomic ions? Sulfate, right? Sulfate is polyatomic ions. And these polyatomic ions, for instance, it combined with a metal because it is ionic compound. So metal with a, look at the metal with a polyatomic ions. Transition metals with a non-metals, right? So main group metal plus non-metals, right? That's how it made, you see? Non-metal came up, make a aluminum oxide. So here, non-metal plus transition metals. Here, polyatomic ions plus metals. So sodium sulfate. So these two metals, when you write a compound, it become in here. Sodium sulfate. One more example. So potassium nitrate. Is there any subscript for potassium? No, it's not. Because nitrate is a negative 1. So it's going to be 1 in here. And potassium is a 1 plus. So here, the name as it is. You say sodium, sodium. And you don't need to say sodium you don't need, and then sodium and then sulfate, SO4. Sulfate. So the name would be sodium sulfate. Yes.
What about when you have a moniker like monosodium?
Yes, we are coming there. Very good point. So what is said? What if the prefix mono or ditri? Do we say that? We don't say that in here. We are coming up. We're gonna be doing in covalent compound.
So that's whenever you.
Yes. So covalent is non-metal plus non-metal. Remember that? So non-metal plus non-metal form a covalent compound. Give me example of covalent compound. Give me example of non-metal and non-metal.
Carbon and oxygen.
Carbon and oxygen. Very good. Carbon and oxygen form carbon monoxide. It form carbon dioxide. Two examples, right? Now we can say here we don't look at the charges. We just look at the prefix of carbon, prefix of oxygen. If the left side, the one is the front, the one is starting off, the left side atom is 1, you don't say mono. But this one is say mono. Right side, mono, ditri, say like that. So carbon, carbon monoxide. See? And this one is a carbon, yes, dioxide. Carbon monoxide, carbon dioxide, like that. And you do not say here in the middle carbon in the Roman numeral, no. The same way, in here, main group element, main group ionic compound, you should not say dialuminum trioxide. Why not? Because this is the ionic compound. The ruling is different with ionic and covalent. Okay, we are going to be solving more problems. That will be more clear. Okay. And then acid could be two types. Binary. Binary means two, right? That means two atoms involved. For instance, here binary, and what is acid start off? Always with H. H with a something kind of anion. H with a anion. It has to have a H in the front. Have left side have to have a H. So H in here first. You put an H first, and then binary means one more atom. Have to be anion. Give me example of anion, single atom. Sulfur. Give me one more. Look at the periodic table. Who are the anions? Oxygen. Oxygen doesn't make actually acid, because oxygen acid is here, second one, without oxygen.
But what about whenever it's an OH?
OH is going to be water, and HO would not be acid, because even though OH, let me write down, OH, right? It is actually anion. So it's not a molecule yet. And it's not acid because we have a 7 plus of oxyacid. So if you look at chlorine, that would be a good example of binary acid. If you have a hydrogen iodide, that is a good example of binary acid. Also, even though binary, HCN could be another example of binary acid, because it doesn't have oxygen. Now the question is how it is binary. It is kind of exception that even though it is not a binary, it follows the rules of nomenclature of binary acid. Question.
The name of HCN. I don't know the name.
Yeah, it's going to be same. Let me write out.
Yes, sir. Thanks.
Yeah, so HCl, right? So how it goes? The naming goes for the binary is you first write hydro in the front, hydro, and then chlorine become, because acid name is for primarily is oic acid. Oic acid. This is the basic name of acid at the end. So for the binary, you should say first start with the hydro. For the binary acid, in the front would be hydro. The left side, you first say hydro. Then chlorine becoming chlorine becoming
Chloric.
chloric acid because it following its base name oic acid. So hydrochloric acid. Tell me HI.
Hydrogen ion.
Hydro, first would be hydro, right? Then iodine following its base name. Exactly, hydro iodic acid, you're right. Hydro iodic acid. And this one also following binary acid rules, which is hydrocyanic acid. You see? And what the oxy question? What the oxy acid? Oxy acid is the polyatomic ions who has oxygen in it. Can you give me example of polyatomic ions who have oxygen? Sulfate, yes. So H with a sulfate, right? SO4. So SO4 was 2 minus, now it's 2 coming here, right? And one more example.
5-theta.
So yeah, H3PO4, phosphate. Phosphorus was 3 minus, as you say, so 3 coming here, right? So H2SO3. Okay? So I can write sulfate, this is sulfite. So this, right, let me write the name of SO4. You said SO4, right? What is the name of this? Sulfate, you write, sulfate. And SO3. What is the name of this? Sulfite. There you go. Sulfite, right? Sulfate and sulfite. This 8 converting to E. So this name is sulfuric acid. This name is sulfurous acid. You see what happened? If it coming sulfate become acid, 8 becoming eke. 8 becoming eke. If acid coming from ite, then ite becoming as a us. You see? And we do not say hydro in here, do we? No. Hydro only for binary. But in oxy acid, we do not say hydro. So this is hydro only in here. But the base is always same. The one more thing is, binary acid always use eke. Always eke. You see? Always eke. Hydrocyanic acid, hydroiodic acid, hydrochloric acid, you see? They always use eke. And for oxy acid, eke only for ite. You see? Ite become eke. 8 actually 8 become eke and ite become us. So go back to covalent. In covalent, we only care about their subscript, and subscript come as a prefix, right? 2 becoming as a di. You see, di. See. So this is number 1, number 2, number 3, number 4 type, number 5th, and number 6th. Or you can say 6 here, this you can say 7. So oxy acid 6 and hydrate salt 7. Hydrate salt actually easy one. Just as salt. What is salt mean? Any cation and anion together. Like sodium sulfate. Like for instance, sodium sulfate is salt, or copper sulfate is salt. So there is some molecule have some water binded with it. That would be 5. Copper sulfate has a 5 water molecule. The name would be copper sulfate pentahydrate. So copper sulfate pentahydrate. Copper sulfate pentahydrate. So the uniqueness in this name is only saying the word penta. That's the uniqueness. This kind of hydrated salt, you use number of water as a prefix of hydrate. Any question? Yes, sir.
The acid SO3, what is the name? Sulfurous.
Sulfurous.
Sulfurous. Yes, sulfurous.
Yes, sulfurous. And go back to main group. Main group is metal, non-metal, and then IDE, aluminum oxide. You see, aluminum oxygen become oxide, right? And transition metals, you look for their charges. Iron charge was 2, so that's why it comes as a Roman numeral in the middle. Iron is 3 plus, become a 3 Roman numeral. And then polyatomic ions. The third type, right? Let me one type. This is 2 types, 3 types, and this is the third. And this is the actually this is the example of 4 types. This is the fifth, right? And hydrated salt is only for, I have one example in here. Any question with it? Any question? We can go for practice problem. Yes, sir.
Yes, sir. Can you give me one example for hydrated salt?
Hydrated salt or?
Yes, sir. Number 7.
Number 7 is, oh yeah, one more example. For instance, if we have one more example as a sodium sulfate, right? This is salt, right?
Yes, sir.
It has a 10 molecule, 10 water. So then you write, what do you write? You write, let me write on the top, in here, sodium sulfate deca. Octo means 8.
I was trying to count.
Oh, you trying counting? Okay. Deca hydrate. So deca means 10. This is it. So deca coming as a prefix for 10. So as a deca. You see? Yes. You had a question. So now I would like to give you some problem for you to solve.
Hi, are you guys
What time you start?
new?
Oh, it's already done. Just getting off, okay?
Right, no problem.
Thank you.